Welcome to this evening's event, Sustainable Future for European Transport, Levitating MagRail Trains on Existing Railways. My name is Dave Keating. I'm going to be guiding us through tonight's discussion of a really exciting topic that fires up the imagination. Now, we know that the European Union has the most widespread high-speed rail network in the world. It's really been a leader and a champion on high-speed rail. However, high-speed using magnetic levitation, or maglev, hasn't really taken off here after several failed earlier attempts. And meanwhile, Japan and China are moving ahead on the technology. Now, the EU is trying to reduce the carbon footprint of transport, and high-speed rail alternatives to aviation for routes within the EU are really essential to that effort. However, the standard high-speed rail is capable of speeds of up to 300 kilometers an hour, which means it has a limited ability to replace distances of between 1,000 and 3,000 kilometers. High-speed tracks are also, obviously, very expensive to build. So how could Europe catch up on maglev, which has the possibility to allow passengers to go quickly, faster, further? Today we're going to be talking about one specific idea, one technical possibility, maglev trains that can levitate on conventional railway infrastructure. The possibilities could be really significant, but is this really a viable technology? I'm going to be talking to the experts this evening to find out. So, let's get started.
Ladies and gentlemen, this is Captain speaking. My name is Ben Pachuck, and on behalf of the whole crew, I would like to welcome you aboard MagRail. In a moment, the lights will go off and we will show you how we can travel in the 21st century. We can guarantee that you will not be locked in the room for countless hours prior to a delayed departure. You will not be unexpectedly rerouted by bus to another event that you were not interested in, and that you will get to the end of this meeting without any turbulences. This time, no need to fasten your seatbelts. Just ensure that you are comfortably seated. Thank you for choosing Nevomo, and enjoy your levitating ride. Ladies and gentlemen,
So there you have a little taste of what we're going to be talking about. Let's hear more about these tests that have just been conducted. I would like to welcome to the podium Ben Pachuck, who's CEO and co-founder of Nevomo. Ben?
Thank you, Dave, for this introduction. Thank you, everyone, for coming. It's a great pleasure to see you here and have so many guests online. It's also a great pleasure to see so many friends in the room and people who already, since many, many months, been interested and supportive to this technology, to this approach. I have a special pleasure to welcome very honorable guests, including Mrs. Ruckmacher from the European Parliament, two other members who will be joining us soon, Mr. Giseke and Mr. Marinescu, other EU institutions, including Mr. Schäfer from European Innovation Council, Mrs. Tournier from European Agency for Railways, Mr. Romf from EFOC, Mr. Wołowiec from one of potential users of this technology, CPK from Poland, and many other stakeholders from European institutions, from clients, our investors, and partners. We're going to be speaking today about the future of mobility, the future of transportation. It's no doubt, I guess, for anyone in this room that this world is undergoing a change. The whole mobility sector experiences vast problems, vast issues. All the current modes are congested. We experience terrible delays. The emissions are absolutely too high to be accepted. And one mode is very well positioned to help to change this. It's rail. It's rail, which has been with us for almost 200 years, which has enormous advantages, but we strongly believe that it now requires an upgrade. It requires a new digital layer, which will take it to the 21st century. We've identified a couple of issues that rail faces today, and they are mainly linked to the interface that we are using for propelling trains at the moment. Using steel wheels running over steel rails, it's a perfect interface for guidance and for maintaining cruising speeds. But if we use it for acceleration or braking especially, it's really not so great. The braking distance for 300 kilometers per hour, it's about 4 kilometers. It's really too much if we compare it to road transportation. It all really hinders a lot capacity of lines, so we have a lot of bottlenecks on the network. And another interface that is limiting the performance of the system is catenary. Nobody is really able to run operationally faster than 350 kilometers per hour. And this prohibits railways to efficiently compete with aviation on medium haul routes. If we want to add capacity, we have to build new lines, or we have to think about technologies like maglev to also increase the speed, but it all boils down to one thing. We have to build new infrastructure, which takes a lot of time and a lot of money. At the same time, railways are experiencing growing competition from other modes of transportation, especially automotive and aviation, especially the first one becoming greener and more competitive. At the same time, very ambitious targets, especially here in Europe, Green Deal, which expects the passenger traffic to double by 2030, and it's really going to be very difficult without a major technological shift. So let's now try to imagine how we can tackle this and imagine an upgrade for rail, which would allow us to double the capacity, half the travel times, and that could happen at a cost no higher than half of the cost of building alternatives. And that could be available very, very soon. We are not reinventing the wheel. We are upgrading, supplementing an existing system that has proven for centuries to be one of the most efficient modes of transportation. Let's think about a bicycle to which we add an electric motor and a battery. A bicycle is great by definition for its purpose, but once we add these two elements, it becomes even greater. And this is what MagRail technology can do to existing railway infrastructure by enabling it and adding extra features. This is the path how Nevomov believes the railways can be moved from the current system to the really most performant mode of transportation in the 21st century. It includes steps, because we believe it has to be a very flexible approach. We call it an evolutionary revolution. So it's a revolution from one point of view. From another point of view, it happens in phases, so it's an evolution. So we start with applying linear motor propulsion only. The system is called MagRail Booster, and it will be announced publicly in 2 weeks. We will show the first vehicle running without a locomotive. This is a game changer. This adds a lot of capacity and a lot of flexibility of operations. So finally, rail, especially for freight, will be enabled to compete with road transportation. And then the second step on some routes, and this will be shown in a moment today, is the high-speed levitating MagRail, where we can increase the speed on existing normal lines up to 300 kilometers per hour, and on high-speed lines up to 550 kilometers per hour, to make the railways competitive towards aviation on some routes. And we've done it all in such a way that it's going to be interoperable in the future with Hyperloop when it's ready for implementation. And the beauty of this approach is the flexibility. So infrastructure managers together with operators can decide on which route they want to apply which version of the system. And it's also very much in line with all the efforts happening now in Europe to extend the existing high-speed network. So the more high-speed lines we have, the more lines we can then transform into this fast 550 per hour version of the system. So with Booster, as said, we just add simple modification, linear motor mover beneath the vehicle with permanent magnets, and the stator placed on the sleepers between two rails. And for the full high-speed MagRail, we've designed a special bogie because the vehicle has to be a lighter one. So the bogie you will see in a second how it works. And we also add magnetic beams on edges of sleepers. So instead of 2 parallel rails, we have 5 lines, including propulsion, electromagnetic propulsion, and levitation, and it works more or less like a surfboard. So the part with electromagnets in the infrastructure, it creates an electromagnetic wave, and the magnets on the vehicle pick it up and start the vehicle to move or to brake it. There's going to be an enormous impact on capacity. We can more or less double it. We've run already a number of feasibility studies with major railway and logistics players in Europe. We start to do the same in the Middle East. For passengers, I will use an example of Stefan, who has to go to Berlin tomorrow because the direct flights were booked and there is no relevant railway connection at this moment. He has to go via Munich and still spend half a day. He would be able to go there within a bit more than an hour if this kind of technology was implemented. We can indirectly cut really a lot of CO2 emissions using this technology. If we manage to shift traffic from roads and airports to railways, because railways become much more attractive, we can really allow the EU to meet its targets, maybe not fully by 2030, because it's still not enough time, but by 2030 it becomes really very realistic. And the most important part of it, we have in Europe about 250,000 kilometers of existing railway lines. In the whole world, it's more than 1 million kilometers. If we look from sustainability perspective, if we wanted to build new maglev lines, for example, how many resources we would have to spend, and how much money and how much time we would need to get a network effect. With MagRail, we can get a network effect immediately because it's interoperable. So existing trains can still run on existing lines, but also booster vehicles or levitating MagRail trains can run on the same lines. So we can speak about deploying this technology in short years instead of decades, which would be needed, for example, to build new maglev lines. And please have a look at this video.
Welcome to the future of rail travel. At Novomo, we are committed to taking rail transport to a whole new dimension by combining proven solutions used in existing railways with state-of-the-art technologies. Our MagRail products are developed for both freight and passengers and intended to strengthen the competitive position of railways. All MagRail products do not require the use of locomotives, allowing for independent single or multi-wagon movements, and thanks to automation, they provide the highest level of safety. MagRail Booster allows for a quick retrofit of existing rolling stock and railway tracks with linear motor propulsion. This technology has been developed to improve existing rail services, providing traffic automation and new digitized method of infrastructure electrification for higher flexibility, greater capacity, and enhanced dynamics. MagRail Booster allows increasing loading limits on inclines and quicker re-acceleration of freight trains, as well as eliminating additional locomotives. It can also be used on non-electrified lines or in narrow tunnels. One important feature of this system is that single booster wagons can move independently without being connected to a locomotive. There are plenty of possibilities for new applications in which wagons form small groups instead of full train sets. Good examples are freight terminals and industrial facilities, where a high degree of flexibility and movement automation is much desirable. MagRail Booster technology is also applicable to passenger trains. It helps improve the technical parameters of existing vehicles, allowing them to accelerate and brake faster. MagRail changes the way in which we think about passenger rail travel experience. Instead of running on fixed timetables, trains are available in variable capacity, constantly adapting to current demand in stations, similarly to metro systems, but for intercity trips. With wagons now being able to move on their own, adjusting the number of carriages in one train on the fly is simple, adding an extra layer of adjustability to the operations, making them more flexible. Our autonomous and safe levitating high-speed MagRail running dedicated passenger vehicles at up to 550 kilometers per hour is a frictionless ultra-high-speed rail of the future. Increasing speed and network capacity will significantly reduce travel times, accelerating the shift from road to rail and enabling railways to compete with short and mid-haul aviation. For now, increasing demand for more traffic requires expanding existing or building new railway infrastructure. With MagRail, we only upgrade railway lines in existing corridors with new components. We reduce the adverse environmental impact as compared to alternative approaches by limited usage of natural resources and no additional land occupation, resulting in implementation times taking years instead of decades. Europe already has a dense railway network, but it lacks capacity and traffic flexibility. Unlike other magnetic rail systems, MagRail is interoperable with conventional rail, solving the challenges of no access to key locations like city centers and inability to create a coherent network of connections. This feature makes MagRail a one-of-a-kind, scalable, and future-proof transport solution. We start building the MagRail network with cargo booster on closed infrastructures like industrial zones, terminals, and harbors, where automation and performance are key. We continue to smoothly grow with local implementations on passing tracks and inclines on key cargo routes, in parallel to passenger booster deployments on regional lines. Afterwards, these sections are connected with each other and to the international rail network for full-fledged operations over complete lines, ultimately developing into ultra-high-speed passenger travel with the addition of magnetic levitation. In the future, even Hyperloop pods would use MagRail infrastructure as last-mile connectors to centrally located stations. This way, MagRail seamlessly expands into a global, interoperable, and paradigm-shifting transportation system of the 21st century. Our mission is to support railways and governments to become more innovative in order to meet their ambitious targets of zero emission, agile modal shift, and increased capacity of transportation systems. With MagRail, we will all benefit from less traffic congestion, cleaner air, and easier access to travel. Let's step into the future with Novomo.
So we've seen what's going to be the impact of this technology. Some of you may wonder, okay, not so bad animation, okay, presentation. I like it. I've seen it so many times. Does it work? We had this discussion with Keir a couple of weeks ago in the European Parliament. Okay, when we can see it working. So finally, after more than 3 years of really hard work of our engineering team, we can announce today that we've made it. For the first time in history, we've managed to levitate a railway vehicle on an existing railway line. So this is the impact that we can offer to the transportation sector instead of building new lines, new redundant infrastructure, which again, we should still continue. But to reach a network effect, we need to put a new digital layer on top of it. And this is the change that we are offering. So it's a more than 700 meters long test track in southeastern Poland. We've tested one bogie, which levitates. So we need to get a second one and put the vehicle on top of it, which of course we will do with industrial partners. We don't have an ambition to become a train manufacturer. There are many great train manufacturers in Europe, and we start working with some of them already. But we developed the interface, the propulsion, the levitation, and the low-level control system. And let's see it. Thank you. I wasn't sure you're going to do it, so thank you very much for this. Let's move back to the slides and take them briefly. So this would have never happened without this incredible team that we've managed to build inside Nevomo and industrial partners, our investors. I cannot name everyone, so I will just keep it as brief as possible. So I want to say a special thanks to the whole team of co-founders. Kasia Folianty, Łukasz Milczarek, Stefan Kirsch, Kacper Koniarski, Jacques Berebi, who's also our investor, Heather Private Equity, EIT New Energy. Support we have got from Vlada Slash as our first angel investor, EIC Accelerator, which is a critical source of funding for us, NCRD in Poland, and especially, really especially to the technical team of about 60 engineers who have spent countless hours working on this. I cannot name everyone, but really deep thanks for everyone involved. And I will pass them through the CTO, Paweł Radziszewski, Sebastian Kałuża, and Marcin Nikoniuk. Thank you so much, guys, for achieving this. And thank you to so many partners and clients who have already expressed their very strong interest in this technology. So what's next? We're gonna start industrialization and commercialization of freight boosters, so elimination of locomotives for freight use next year, and with the help of EIC, we're getting there. So we're gonna announce the product publicly in 2 weeks from now in Gdańsk at Traco Railway Fair. So you can come and see how it works and how it looks like. And then we're going to continue with industrialization of propulsion for booster. Then the next steps for the levitating version are a full-fledged homologation center, and we already have a proposal from the Italian railways to proceed with this. And since we're meeting here today in Brussels, it's a great moment to invite you to become part of this evolutionary revolution. So for the infrastructure managers and operators, it's a great opportunity to become our first clients. For industrial partners, and we already have quite many of them, but we need more to become part of it as a supplier. For investors, to create a new segment of the railway market. And of course to the public sector and European Union, represented here by so many great people with us, to help us on the regulatory front on one hand, and then of course help us still with the funding to get to the final version of the levitating product. Thank you so much for listening to me. I think we are still on time as promised, and happy to answer any questions.
Thanks a lot, Ben. So you can have a seat up here with me. I have some questions for you. Now, you guys can ask your questions to Ben using Slido. You can also, for the 2 following panels, ask your questions that way. And well, actually, Ben, if you could hand me that tablet there, and I can see
what's happening.
Exactly. While you guys are thinking of some possible questions, I did have a quick question for you, Ben, which was that you mentioned that we're now talking about years, not decades. And this is a pretty big moment, the test that's been conducted. What do we really mean when we're talking about years versus decades? What is the test? Can you walk us through what does the test change in terms of shortening the time scale that this is possible?
Okay, so first of all, we know that the system works, and especially we know that combining levitation with propulsion, linear motor propulsion, on existing line can work. So we can start with implementing the propulsion, industrializing it, and we know that later on, when regulatory framework is ready, and when we have everything prepared, so the full levitating vehicle ready as well, we can add the levitation elements on some lines and introduce the high-speed vehicles. So this is the critical element that from now on we can really move to from R&D phase to engineering and industrialization phase of booster first, and then continue with working on the levitating version in a broader consortium of industrial partners.
Okay, so we've had a question come in for you from Phil Mortimer. The question is, how has the market for this new technology been determined? What are users' critical requirements, and how does the new technology address these? So who is the market for this?
So the main market is, of course, infrastructure managers and operators. We have an unbundled market in Europe. And then for the freight version of booster, of course, also ports, terminals, logistics companies. So the market is broad, but also segmented in a couple of user groups. And we started, in 2017 being very heavily inspired by Hyperloop. And then in 2018, we realized, okay, let's have a look whether this could be implemented in a bit different way than proposed initially by Elon. And that's how we came up with MagRail. which we believe is kind of a missing component, which can allow to transform existing great network with amazing assets, the land beneath the lines. This is the only potentially high-speed infrastructure reaching city centers. So we have to do something more efficient about it. Then we, of course, started talking with clients. The first ones to pick it up were the Italian railways. Then we have the partnership with the French since this year, and many others. Stefan can tell much more about it when he's on stage. And this is how we basically shape the system now in talks with the clients to have the final industrial version of it.
Okay, we've got another question for you here. By the way, if you're in the room, you can scan the QR code on the side walls or up on the screen to send in your questions via Slido. So the next question is from Robert Colahan. Will you license the MagRail technologies, and when might these be available in North America?
A great question. Yes, we're going to license these technologies. Of course, the system has to go through safety approvals first. So here we plan to keep the role of system integrator to be able to run this process very smoothly, of course, with industrial partners. So this way we're going to go through a couple of first implementations, and once we have the first safety approvals, we plan to license it to major railway suppliers, because this is the only way to scale it at a proper pace which can allow us to achieve the climate goals. And concerning the North American market, so far we've been active in Europe and in the Middle East, where we are also getting very positive responses about this technology. And actually North America most likely will be the third target for us. And we're plan to start some activities there next year.
Okay. We have another question from a Robert here. This one is from Robert Preston. What is the cost per kilometer of your systems, and how does energy consumption compare with conventional electric traction?
Okay, so the cost for the non-levitating booster version is about 6 to 7 million euros per kilometer of a double track. And if we're talking about the levitating version, it's up to 9-10 maximum. This is the current cost. Of course, we hope this will decrease over time with economies of scale. Concerning energy consumption for the pure propulsion, we believe, based on the current test, we should be able to optimize it by single percentage points per unit of freight or passenger transported, because the linear motor can help us to achieve that. And for the levitating version, it's really hard to say very specifically at this stage, because the prototype is one thing and the industrial version is another one. The results are still promising, but they still need some optimization, and this is something we will be working on in the coming quarters.
Okay, and one last question for you. This comes from Gustavo Bomfim. The generation of thrust forces with a linear motor certainty also generates vertical forces. Would sleepers on current rail networks also have to be retrofitted to withstand these forces?
Okay, so this is one that I would have been able to answer if I became an engineer, which was an option one day. But finally, I didn't become one, so I will kindly ask Kacper Koniarski.
Yes, so for that we do have
help me out with
Casper online with us. So Casper, could you take that question? This is Casper.
Yes, hello. Yes, wonderful. Thank you very much for having me here. It's a great pleasure to be a part of this. Yes, so concerning the question about the sleeper and the ballast and general track stability, this is something that we are already working as a solution about. First of all, we have a solution on how to mount the linear motor propulsion and the levitation beams to existing sleepers such that the system works properly. However, this may not be the best implementation in terms of scale. Right, so the actual best option would be to develop a sleeper of our own type, for which we've also already undertaken some discussion with very settled industrial partners. In this way, the design of the sleeper itself would be such that it would withstand the forces and blows that come from the runs of the MagRail system. And this applies both to the high-speed levitating MagRail and our MagRail booster solutions. And yes, I think this would be the answer to the question. I hope this answers this in full.
Yes, I think so.
Yeah,
Thanks a lot,
thank you.
Casper. And Casper will be nice enough to help us out with some technical questions also during the panel. So we appreciate that, Casper. So Ben, I think that'll do it for now. We're going to welcome you back in just a short bit for the second panel.
Thank you so much.
How about a round of applause for Ben?
Thank you.
And next up, I would like to welcome to the podium Dutch MEP Dorian Rookmaker for our keynote address. Dorian?
Thank you so much. Thank you so much, Nuvoma, for having me here. I'm really thrilled about the innovation presentation that I saw just now. I think innovation in Europe, this is just what Europe needs. We need innovation to combat the brain drain and to see to it that a sector, especially the rail sector, is attractive for young, intelligent people. And we see all kinds of developments in China. We've seen them in Japan, but we've seen not so much innovation in Europe. And this is a sad thing, because we in Europe tend to think that we are a rich continent and that we will always stay this way. But I don't think this is necessarily the case. So we need to speed up, as to say, and get our act together. And I'm a politician, and when I started here in the European Parliament, I was immediately taking up the plea for high-speed rail in Europe, because I think it's far better to invest as a political group than to make rules and regulations. I think if you are a politician, you can do two things. You can step on the gas pedal and invest, or you can put on the brakes and do this with rules and regulations. And I think it's far better to invest, to be a positive force for society in general. And I think if politicians put their attention to the more positive side of making policies by investing, this will enhance the prosperity of the whole continent. For instance, if you bring the Europeans together with high-speed rail connections, you will create a lot more economic growth. I think rail is a real good equalizer because everybody can use it. It doesn't matter if you're young or old. It doesn't matter if you are disabled in any form or shape. It doesn't matter if you're mentally ill, if you're old, if you're not capable of using a car anymore. Everybody can step on a train. And when I see this new innovation here, I'm getting more and more excited. I was in Warsaw, and I've met the Nuvoma guys earlier, thanks to Ben, and it was a real nice visit. But now I see this, and I want to address this question. I would like to that you can point out which are the best tracks that we can start with this project in Europe, because I think we should start with this project in Europe. And I hope you will point out to the Netherlands, because of course I'm a Dutch MEP. But if it's not the case, I think it's good that we start somewhere in Europe, because this is such a beautiful technique. And as you say, it's cheaper than high-speed rail, and it is environmentally friendly in a sense that you don't have to build new railway lines. You can put it on existing lines. So This is, of course, a technique, but I think politicians should innovate as well. And this means that we should concentrate on being an enabler for society instead of a regulator. And this is a complete paradigm shift. So if we are an enabler, we have to step aside from political discussions about what technique to use. I think this is not a task for politicians. We're not capable of doing this. We just want people to be able to be transported from A to B in a safe, environmentally friendly, and fast way. And the same goes for good. Whether this should be high-speed rail, conventional rail, or MagRail technology, this is, I think, up to the sector in itself. And I won't take too much of your time, but I think when I started promoting high-speed rail, I became involved with the sector, and I found out that the sector needs some innovation as well, and I don't mean technical innovation. I mean a different mindset, because unfortunately the train and the rail sector is divided, and everybody's looking at its own interest, so they are a little bit short-sighted. And I mean people who are working in the rail sector, the unions, I mean the operators in the sector, and I mean all the organizations that are around it. And I think it's time for us to innovate in this sense, that we look at the customer, the end customer. And if we can all focus on the end customer, whether it's freight or it's passengers, then we can come together and we can decide amongst each other what is the best way to go forward. But we have to think about the added value that we can deliver to the customer, same as, for instance, I think this is the same that we can see in politics. In politics, we are also looking too much about our own interest, our own self-interest. We're short-sighted, and people get fed up with it because we are only thinking about our own interest. We can see that in aviation as well. For instance, people are talking for years and years now about a single European sky. I think people are much more into rail here, but the single European sky, for people who don't know it, it's a plan to regulate the capacity in the sky in such a way that the planes can fly as efficient as possible. But because of all these local interests and all these local controllers, the single European sky isn't flying, and it's not getting off the ground. And this is exactly the problem, I think, in Europe. We have too much operators thinking about themselves, and we have to think about the international customer, the international passenger, and come together and step onto it and take this technique to a new level. And this is my contribution. Thank you.
Thanks very much. So you can have a seat up here. Actually, we're going to move now on to the second panel.
There's one thing I forget, by the way, is that we are always looking at the governments and politicians to decide what we're going to do next. But I want to, can I do this right now? Are you sure? I want to draw your attention to, there is a citizens initiative. It's not mine, by the way, but I support it heavily. I support it strongly. You can sign up for a citizens initiative that is asking the European Commission to really take the initiative of creating a high-speed rail network through Europe. It's technique neutral in a way. So I hope that you can all sign up and share it with all the people, because you're an international audience right here. So we need, or not we, but the initiative needs 1 million signatures from 7 countries. And if we can get 1 million people to sign, then the European Commission will take up this initiative, and this will create a bit of speed in the whole international rail network. So.
Thanks so much. In fact, that was an innovation of the Lisbon Treaty. The Commission must reply if you
Yes.
get to 1 million signatures. So a good reason to go ahead and sign up. So have a seat up here. We're going to move on to panel one. So panel one is going to be looking at the why. Why does Europe need this? So let me invite our panelists up here to take a seat. First of all, we have Dirk Rumpf, who's Managing Director at IFOK and former DB Nets board member. Dirk, you can have a seat up here. Then we have Nitiana Tournier, Innovation and Technology Coordinator at the European Union Agency for Railways. We have Alexander Voljevic, Deputy Director for Railway Stakeholders at Centralny Port Komunikacja. Yes, what he said. It was a particularly challenging one. And Stefan Kirch, who is CBDO and co-founder of Novomo. Stefan can take a seat right up here. So Dirk, I'd like to start off with a question for you. So now you're combining a kind of unique perspective here because for many years you were a board member of the EU's biggest railway infrastructure manager, and now you are advising the German government. So what is your view on the pace at which ultra-high-speed railways can be implemented in Europe? I was just talking a bit with Ben about this. What conditions would you say have to be met among all the different stakeholders involved here in order to accelerate this process, and which market players are going to be crucial for that speeding up?
Okay. Yeah, first of all, let me start by saying I really believe in the impact high-speed rail and ultra-high-speed rail can have in changing the way in which we perceive mobility. I could experience this myself. I used to be in charge of the high-speed project in between Berlin and Munich. This line was introduced by the end of 2017, and by that time the railway market share was below 20%. And by the end of 2018, so just 1 year later, the railway market share grew to more than 50%, and it's still growing. So high-speed rail can really have an impact, and this is an experience that we had all across Europe. When it comes to introducing ultra-high-speed rail, actually it's a difficult question. Normally, building a high-speed rail line takes about 20 years. In this case, as we just heard, of course, the time of building a stretch is not there anymore. But on the other hand, we have a couple of challenges that need to be overcome. So on the one hand side, I think homologation is an issue. It takes a couple of years usually. And as you just pointed out, the railway sector is not known for being extremely innovation friendly. So it's a challenge how much time we will take for homologating, especially since we are talking about cross-border traffic. So we have different technologies, different standards in different countries, and the question is, how can we overcome this? Then we need to convince vehicle OEMs to equip their vehicles with the new technology, and on the other hand, it's about an infrastructure manager to partner with. So it's a number of challenges, and from my perspective, it's absolutely crucial to build trust in the new technology. So the first step I would recommend to take is to build a pilot project on a larger scale than the current one, which I think you're intending to do anyway. And then it's about partnering. Partnering with industry players, with OEMs, with infrastructure managers. It's about convincing politicians. It's about convincing administration. And what I personally think is crucial, start early on collaborating with the regulatory authorities and figure out what the critical points are going to be. The starting point for this, and this has been mentioned a couple of times before, is do something to convince that this technology is real. So I would personally start with introducing the railway booster. do it on short stretches, and make sure that people see that this technology offers higher capacity and higher flexibility than the conventional rail would do. And this can happen in the course of the century.
So you mentioned regulators there, so a good point to turn to Nitiana. So as the ERA's representative, you're mostly focused on the technical viability here, right? So when you're looking at different rail solutions, you want to know, are they technically viable? Can they be standardized? And can they be converged in a way that is compatible with existing railway assets? So do you think that a kind of stepwise approach that we heard described by Ben in his presentation, so that would be testing of particular components of ultra-high-speed technologies as a kind of gradient as we go approach, is that a good way forward when we're specifically talking about the regulatory aspects here?
Okay. So the answer will be definitely yes, and that's the approach which Nevermore has taken, and that for two reasons. The first reason is that Nevermore's technology is in brownfield innovation. It means it takes into account the existing railway system. So we know that for rail, its strength, but also its the constraint is the existing legacy system. And to integrate a Nevermore linear motor in the system, you'll need to have the topology of the tracks and the planning of retrofit of the infrastructure. And that's quite important task. The second reason I see is it has been already presented by Ben that in railways it's an open shared system with many actors having different roles, different responsibilities, but also different interests. So there is a need to really engage all those stakeholders together and schematically the different steps that will be necessary to bring the solution to a scale have been already presented by Ben, actually. So its operating condition with the safety and technical requirements, its selection of pilot lines, apparently it has been already done. And for this second step, it's not only purely technical, because you also have to consider the market, and the question has been already asked, and the financial, and that is a question for the investors too. And the first step will be the upgrade or retrofit of the existing line. And there is another challenge, because operation needs to be continued, and priority will be always given to operation instead of retrofit. And that's really a tricky task. And as it has been said, the last part will be scaling up the solution and testing it in real condition with the dual mode, conventional and ultra high speed, with the necessary teams for operation, because it's a new system, even if it's proven, but it's also a new operation. So you need those skills to be present. Maybe we don't have them today in our sector. And the last part, as it has been said, will be the authorization of both the fixed installation and the vehicle. And here I speak as representative of European Railway Agency.
So let's talk a little bit about how UHS can fit in and complement existing high-speed projects. Alexander, so CPK, a little easier for me to use the acronym for the region. So it's currently having this really big project, actually the largest transport infrastructure project in the region, which is going to include 2,000 kilometers of new railway lines. But specifically for us, key to that is that it will include Poland's first high-speed rail line. Poland hasn't yet had any high-speed rail. Now there's this project for getting to the airport, to Warsaw Airport. So how does CPK see the potential of UHS and the possibility of using it on these new lines, maybe even including it now in the design stage. Is that something that's on the radar, and what conditions would have to be met in order for projects like this or other new high-speed rail lines to be building in these UHS, maybe UHS-compatible elements?
Yes, indeed. CPK is the biggest effort in European Union, in Poland, in the region, to deliver a comprehensive intermodal system of transportation. It emerged in 2017 from the concept, and the result will be delivered in 2028, the first results. I'm mentioning this because I believe that we have the same DNA of innovators as Nevomo. Because to start with such a huge project placed in the stable and routine industry sector as a railways, you have to be a dreamer. You have to have a vision to deliver something special. And this is very much about CPK. And we are very closely cooperating with Nevomo to see when the idea, when the technology will be ready, because this is about the technology. We have seen this promising advantages, fruits of the technology, but before this, if we take a step back and we will see the process of investment from the distance, we will see that this is several phases with the several stakeholders in each phase. The first one is a sponsor, a state, politicians who says yes, who say yes, we are interested in this kind of a technology. When you start such a investment project, a huge one, a complex one, then you move after the acceptance approval at the highest level. You move to the preparation, to the planning, to the design, to the implementation, and at the end, at the maintenance and use of it. And in each phase, you need to engage with the stakeholders. So if I were to promise for the politicians to deliver 500 kilometers per hour service, then I have to present a technology which is economically viable and technologically stable, proven. If I move to the phase of planning and designing, I need to have a technical standards, because the designers will ask how to design that kind of a solution. And the same comes with the industry. If I go to the procurement, I would like to procure that kind of a solution. You enter into a very much formal procedure with the bidders. For example, they have a right to ask questions, like 300 questions per procurement, and you have to respond to them. They are very much technical ones. So I would like to have a partner that could help me to respond to the questions that comes from the industry. And finally, once in operation, I would be very much keen on to know the cost of operation, to possible problems and solutions for them. So Nevomo could be a reliable partner for the investors in Europe, in the continents. I hope this will come just in 2 weeks. We will see the solution working, and this is one of the milestones, very important, because the reliability comes with the milestones achieved. So yes, we are ready to follow, we are ready to consider, we are ready once it is proven to implement.
Great. And that can make a big difference down the line if you start planning for those cooperations now. Stefan, so now we've seen the presentation that this has been demonstrated to work on existing railway infrastructure. That will be exciting news for a lot of people, but maybe there's some people that don't think that's exciting news, and that could maybe include incumbent railway players who may get nervous. These are our tracks that we're using. Who are these people coming in and showing a different way to use those tracks. So are you concerned at all about aggressive competitive practices from incumbent players in response to these advances? And would you say, is the idea that this technology is somehow a competitor to operators or infrastructure managers or OEMs, would that be a correct impression?
Yeah, so maybe first of all, competition is not bad at all, because competition keeps sectors agile. If there wouldn't be any competition, I think it would be a quite boring sector, and I think not so many people would come and join such kind of a session overall. Let me talk for a second about the business model of Nevomo, because we see ourselves not as an basically revolutionizer for railways, but we want to enable railways to do better. So we bring capacity, we bring flexibility and such, by not competing with existing incumbents, but enabling them. So Nevomo will not plan to operate railway networks. We do not plan to build own tracks, own trains, operate them, neither the infrastructure nor the trains. So I think it's more like a chance for railways to step up and basically do better with the existing network and the huge assets that are already there. Imagine you would have to rebuild such kind of a network that would cost billions and billions and centuries of railways. Let me give you two numbers, because I think the competition should be the sector towards other sectors and not inside of the railway sector. So railway market has 8% market share in passenger transport. Road has 80. So imagine every 10th car would just pick up one person. Then all trains would be empty all over Europe. Every 10th car, just one person. And this is already doable today. This is before platooning, before electrifying the engines, the combustion engines. This is before self-driving cars. So this is somehow realistic, and it's the same for freight. So the trailers currently running on European highways have more spare capacity than railways are transporting today. So I think if railways are not inventing themselves to some new standard, somebody else will do it, and the new technology is already on the horizon. So I would invite people that get scared or see us as a competition to talk to us, to partner with us, and build a great ecosystem inside of the railway sector, and then compete with other sectors to achieve those goals that we've just talked about in the last hour. That would be my invite, basically, to the sector.
So you mentioned that the new technology is already on the rise, and Doreen, that's what I wanted to ask you about, the geopolitical context of all of this. We know that China is moving ahead very fast on this technology. They're getting quite advanced. In just a few years, they could be having trains at speeds of 600 kilometers per hour, which would allow them to travel 1,200 kilometers between Beijing and Shanghai in just 2 hours, which is very, very impressive. And I think we can be sure that if they succeed at that, they're not going to be content in just investing in China. It would make sense to then deploy that technology worldwide, and that they would eventually come to Europe and be interested in having that technology here. So can Europe take that on? Is it even possible for Europe at this stage to compete on UHS, particularly keeping in mind that, as I mentioned, Europe right now has the most widespread high-speed rail network. It has a long tradition of leadership in rail. Is Europe capable of competition with China on this? And how can the EU give an answer to those developments in China, specifically legislatively, regulatorily? How does the EU make sure that Europe can compete on this?
Well, there are a lot of questions. But as I see it, well, Europe has a couple of great advantages still. We have a highly densely populated continent. We have an industry that is really up to spec still. And we're doing quite nicely at the moment. But of course, as you pointed out, China is around the corner. And I can see the risk that China is coming to our continent. That could be the case. For instance, a country like Serbia would maybe find it attractive to get high-speed rail on low costs. And we in Europe are, well, our European companies are looking across the border, and they're doing wonderful projects in, for instance, Egypt and other foreign countries outside Europe. And I think this is partly because there's not so much work inside Europe. We're not investing enough. And if we're not investing here, you know, it's like the 16th century when all these young guys went to South America and to America to explore. It was not because they were so excited about new opportunities in the first place, but because there was no room for exploration and doing crazy stuff in Europe. It was too conservative here. There was not enough room for nice initiatives. And I think we really run the risk in Europe, especially when we over-regulate. And I'm thinking that we're heading there. You know, every year we put out more and more regulations. Then it will become the case that our own European companies will go somewhere else. And yes, if these companies are going somewhere else, we will get into the situation eventually that also our young, talented people will go somewhere else. And of course, this is not a place we want to go. So as I pointed out earlier, it's not only about innovation in a technological sense. I think it's very important, maybe even more important, that we start thinking about politics and innovation. And that this politics is far more an enabler of new tendencies, new developments, and innovation than it was before.
Well, let's take some questions that have come in.
Add one thing, because you know, rules and regulations are not so much necessary for this new technique. And I think if we, when we look at the 10T projects, for example, we've always have been told that these are lagging behind because of the cross-border stuff and the different technologies and the different standards. So I think we have to start as soon as possible to see if these rearranging innovative, in an innovative way, the conventional lines can be an answer of our cross-border challenges. That could be the case. And if so, we should put all our money into this kind of opportunities.
So let's take some questions that have come in via Slido. Dirk, I'm going to put this first one to you because I think you've had a lot of experience with this. The question is from Julia Umens-Mir. If you only want to use existing rail infrastructure and not add new ones, how do you deal with high-speed MagRail trains in combination with the already existing slow, medium, and fast trains, while the capacity on these rail networks is already saturated or more than limited? Is there a problem with the available amount of track if we're going this route of using existing tracks, not building new ones?
Well, as many of you might know, the capacity that you have on a line depends on the spread of speed that you're offering. So if you would decide to offer only ultra high-speed trains, the capacity would be huge. But if you would offer a mix of ultra high-speed trains in combination with regional ones, slower ones, or with cargo trains, of course the capacity would drop. So this is something that is up for the infrastructure manager to provide the optimum mix of velocities, but at least to have the option to operate on this ultra high speed is something that would make a contribution to the rail.
Stefan, I'm going to put the same question to you, and also a related question here from Jurgen Lola. How long would it take to upgrade and commission the existing rail system to a MagRail system, and what would be the impact on the operations of the rail system during construction? So related question, but specifically also during construction.
Yeah. So as it is an upgrade to railways, we do not have to shut down it for weeks or months. So we could basically like implement and deploy like meter by meter by meter just overnight to grow into the railway network, like as a vision. But as you've seen on the map, like in the visualization animation, we'll start like at specific points. So imagine, for example, we could start at one incline where you have a capacity problem and then heavy freight train could not run with cruise speed uphill. You have to lower the loading limits. So imagine you would just deploy on that 12 kilometer some MagRail booster technology, then it could already bring 10, 20, maybe 30% on additional capacity in the overall network. So we do not have to deploy it basically everywhere. And I think this is the beautiness of the system itself, that punctual and particular installations would already help to overcome some obstacles. We are running, for example, a use case study with SNCF in Paris, in Châtelet-les-Halles, and there would be like a punctual installation just in the sand tunnels. And I think implementing such kind of technology on some 100 meters in the sand tunnels could be done in a week, maybe, over some night shifts. So like a week later, you could add additional capacity if the system is safe and like ready for homologation certifications. We're talking about the future. But we'll start already next year. So currently like searching and negotiating pilots with real world customers, where we'll implement it probably on a closed infrastructure first, and then later on go to the open network, because this is from the hurdles and from what you have to, what have to be approved beforehand. This has to be like properly made beforehand. So we'll start probably in industrial facilities, terminals, and harbors.
Nitiana, from a regulatory perspective, do you have any concerns about the saturation of the rail network being disrupted by this?
Well, actually, the question would be more for the infrastructure manager, because we're not dealing with infrastructure capacity. As I said, in the staged approach, the selection of the pilot lines is really the main starting point to see where it would be profitable, where it would be feasible, and where it will bring additional capacity.
Alexandra, a question for you. This question is from JK. I think it's particularly relevant for the case of Poland. What's being done to encourage more train adoption, lowering prices, flight bans, more infrastructure build, and fast? So as we mentioned, Poland doesn't have any high-speed rail now. The rail network in general is less developed than other countries in the West. What can be done, what is being done from government authorities to try to shift people from road and aviation to rail?
Well, in case of CPK, we are the special purpose vehicle who delivers a brand new railway lines, which means that this is the green field investment. And this is actually applies to Stefan's comments, because this is also it could be a situation in which the brand new technology could be applied easily and without disturbance in the traffic. The Poland is a very dynamic country, and we are introducing several solutions to improve the quality of the railway service. This, of course, applies to the existing infrastructure manager, but the numbers growing passengers in the railways simply proves that this is still a great space to have the improvement. And we are going forward. I mean, this is the environment very friendly for that kind of ecological transportation.
And final question for Mrs. Ruckmacher. This comes from Georg Kern. Where can I know more about this European high-speed signature initiative? Georg is from Eurail Press. So where can citizens go to find this initiative?
Well, let me ask my assistant, because I think he had prepared a slide so that it is for everybody to see. Maybe it can be projected.
Maybe not. But I think here it is.
Yeah, this is it.
So
this is a citizens initiative. This is something that started in the Netherlands. And these people are asking the European Commission to start with a high-speed rail network in Europe, so that everybody, because if you have the right of free movement, well, you should be able to enjoy it, right? If there's no capacity and there's no means of transport to be able to travel freely, then this right has no meaning. So this is why.
Freedom of movement doesn't mean much if you can't move, I guess, in the end.
Thank you so much.
Well,
Share that information together with the other slides. slides
Fantastic.
and videos afterwards so that
Great.
everybody has it.
So I hope you all will sign. I did.
Everybody looks ready to sign in this room, I think. So we'll wrap up the first panel there. Thank you so much. How about a round of applause for our panelists? And so if you guys could just go to the mic table right over there, we're just going to switch out the mics. So you can go ahead and exit out this door. We're going to take a very short technical break now, so stay in your seats. Don't leave. We're just switching the microphones. And when we come back, we're going to move on to panel 2, where we're going to hear an address from MEP Jens Giesecke from the European Parliament to give us more of that political perspective. And we're going to be talking about how. So we've established the why. Why do we need this? And very shortly, we're going to be talking about how do we do this from a regulatory perspective, from a political perspective, and from a financial perspective. The most important, how do we get the money to do this? So stay seated for just a second, and in just about 2-3 minutes, we're going to start. In the meantime, you can watch a short video here on your screen.
Welcome to the future of rail travel. At Novomo, we are committed to taking rail transport to a whole new dimension by combining proven solutions used in existing railways with state-of-the-art technologies. Our MagRail products are developed for both freight and passengers and intended to strengthen the competitive position of railways. All MagRail products do not require the use of locomotives, allowing for independent single or multi-wagon movements, and thanks to automation, they provide the highest level of safety. MagRail Booster allows for a quick retrofit of existing rolling stock and railway tracks with linear motor propulsion. This technology has been developed to improve existing rail services, providing traffic automation and new digitized method of infrastructure electrification for higher flexibility, greater capacity, and enhanced dynamics. MagRail Booster allows increasing loading limits on inclines and quicker re-acceleration of freight trains, as well as eliminating additional locomotives. It can also be used on non-electrified lines or in narrow tunnels. One important feature of this system is that single booster wagons can move independently without being connected to a locomotive. There are plenty of possibilities for new applications in which wagons form small groups instead of full train sets. Good examples are freight terminals and industrial facilities, where a high degree of flexibility and movement automation is much desirable. MagRail Booster technology is also applicable to passenger trains. It helps improve the technical parameters of existing vehicles, allowing them to accelerate and brake faster. MagRail changes the way in which we think about passenger rail travel experience. Instead of running on fixed timetables, trains are available in variable capacity, constantly adapting to current demand in stations, similarly to metro systems, but for intercity trips. With wagons now being able to move on their own, adjusting the number of carriages in one train on the fly is simple, adding an extra layer of adjustability to the operations, making them more flexible. Our autonomous and safe levitating high-speed MagRail running dedicated passenger vehicles at up to 550 kilometers per hour is a frictionless ultra-high-speed rail of the future. Increasing speed and network capacity will significantly reduce travel times, accelerating the shift from road to rail and enabling railways to compete with short and mid-haul aviation. For now, increasing demand for more traffic requires expanding existing or building new railway infrastructure. With MagRail, we only upgrade railway lines in existing corridors with new components. We reduce the adverse environmental impact as compared to alternative approaches by limited usage of natural resources and no additional land occupation, resulting in implementation times taking years instead of decades. Europe already has a dense railway network, but it lacks capacity and traffic flexibility. Unlike other magnetic rail systems, MagRail is interoperable with conventional rail, solving the challenges of no access to key locations like city centers. and inability to create a coherent network of connections. This feature makes MagRail a one-of-a-kind, scalable, and future-proof transport solution. We start building the MagRail network with cargo booster on closed infrastructures like industrial zones, terminals, and harbors, where automation and performance are key. We continue to smoothly grow with local implementations on passing tracks and inclines on key cargo routes, in parallel to passenger booster deployments on regional lines. Afterwards, these sections are connected with each other and to the international rail network for full-fledged operations over complete lines, ultimately developing into ultra-high-speed passenger travel with the addition of magnetic levitation. In the future, even Hyperloop pods would use MagRail infrastructure as last-mile connectors to centrally located stations. This way, MagRail seamlessly expands into a global, interoperable, and paradigm-shifting transportation system of the 21st century. Our mission is to support railways and governments to become more innovative in order to meet their ambitious targets of zero emission, agile modal shift, and increased capacity of transportation systems. With MagRail, we will all benefit from less traffic congestion, cleaner air, and easier access to travel. Let's step into the future with Novomo. Welcome to the future.
Okay, if everybody could come back in the room, we'll get started now with the second part of the event, which will be dedicated to how. How do we get to this future we've been talking about so far? We've talked about the why, now we're going to talk about the how. And to get us started, I would like to introduce German MEP Jens Giesecke for our next keynote.
Yes, thank you very much, dear Mr. Kirch, dear Mr. Pachuck, dear colleagues, and of course I'm happy to see my coordinator, Marinesco, Jean-Marien. Good to see you here. Thank you for the invitation and thank you for your active to have this event. But to be quite open, it was not so easy to get in. The door was closed outside and here we have 30 degrees, so I will make it quite as fast as possible. When I was 9 years old, work starting on something big in my hometown in Lower Saxony. Large concrete pillars were worked out into the earth, cables were pulled, a platform was placed on the top, and at the end, a 31.8 kilometer long test circuit on stilts was created. I'm talking, of course, about the Transrapid test facility in Latin, in Emsland, in northwestern Germany. I don't know if so many are familiar with Latin, but the test facility you should really know. As a little boy, this facility was pretty impressive. Time, and again we rode on our bicycles to test track and to watch the Transrapid set ever new speed world records. Several times I was even allowed to ride on the Transrapid. What an experience. More than 400 kilometers it was flying on the ground. It was clear to me the Transrapid could have been the solution for fast and sustainable mobility for passengers and for goods. A clear alternative for short flights within Europe. In Brussels we discussed always to ban short-haul flights. This was a solution, but unfortunately it turned out differently. A terrible accident, increasing cost pressure, meant the end of Transrapid, at least in Germany. In the region of Emsland, many people are currently saying the Transrapid was ahead of its time, because actually the maglev technology offers exactly what many people want at the moment. A sustainable technology that could be a real alternative to air travel. Therefore, I'm very pleased that there are currently a number of companies in Europe that have taken up the subject of ultra-high-speed mobility. They want to promote innovative solutions like the MagRail. The test facility in Latin is currently sleeping, unfortunately, and waiting to be used again. For example, for extensive tests with high-speed mobility solutions. Our companies in Europe, on the other hand, no longer need to be woken up. They are wide awake and active. They want to advance research, but this requires support, also through politics. Political support is needed, be it in the form of financial research support from the European level or settlement support at the local level if it comes to permissions. As politicians, we must not wait too long. Other countries, above all China, Japan, US, strongly support their companies in this field. We all know the IRA, and there those solutions are very, very fast implemented. When the transfer peat was shut down in 2022, many people in the region said, and in 10 or 20 years, we will import the technology from China again because they have recognized the potential. I do not want that to become reality. I want to enable innovation in Europe, create an attractive environment for research and development, and become an exporter of innovation, not an importer. For this, however, we need clear signals from Brussels and from member states. We need to bring together all European players, combine railways, maglev, and hyperloop knowledge, and work on a European strategy for ultra-high-speed mobility. I think cooperation is needed, and the railways should recognize the added value of maglev technology. It's not competition, which is evil, but it's cooperation with potential, and in this direction we should work together. Thank you for listening, and I think I made it in 3 minutes. Thanks a lot.
Perfect. Thanks very much, Jens. So now I'd like to welcome the rest of the panelists up to the stage. Marian-Jean Marinescu, who's a Romanian MEP. Keir Fitch, you guys can come ahead and have your seats. Keir Fitch, who is head of the unit on rail safety and interoperability at the European Commission's Transport Department, and also from Europe's Rail. We have Michael Schäfer, president of the board for the European Innovation Council. And we have, again, Ben Pachuck, CEO and co-founder of Novomo. Here's Ben coming in the back. So let's go ahead and get started. Keir, I'd like to start with a question for you, because you're coming at this from a couple different angles here. And you've been very involved with Hyperloop projects for many years on the Commission side. What is your view of the technological developments that we've heard about so far today from Novomo? How are those developments being perceived by the European Commission in light of what's also happening on Hyperloop? And do you think that MagRail could be understood as a solution facilitating Hyperloop technology convergence, or something separate?
Well, I mean, I think the answer to the last question is, in a sense, that's up to them, that's up to the market. But I think the bigger question, I mean, the Commission has been supportive of Hyperloop as a technology with potential, particularly the potential, we think, to take us a long way in replacing aviation over short to medium distances with very low energy requirements. But there is always a big issue with Hyperloop that, I mean, Hyperloop, to me at least, makes sense for those long distances, 1,000 kilometers plus. But actually getting to the point where you can build a network that big, I mean, you're not going to do that with your first project. So you start small, and if you start small, the benefits of Hyperloop are, I think, much less obvious. Whereas what Novomo can do, what MagRail can do, is actually do something which leverages some of the benefits of the levitation technology over much shorter distances, and then does provide a stepping stone to actually getting into the tube and taking off at 1,000 kph or whatever. So if everything works as they're trying to develop it, I think it has a lot of potential to do that. I think it has to be said that trying to integrate with rail as well as doing a greenfield technology, I mean, that brings a lot of challenges with it. For Hyperloop, as I think many of you know, we are looking at developing a new regulatory framework from scratch, which obviously means we try and establish a single set of specs at a European level early on, or at least a single set of processes, so we don't have the issues with rail with lots of legacy technologies and lots of different national solutions. If MagRail is going to integrate into the existing rail system, then it is going to have to deal with integrating all of those legacy systems into its product, and that will be hard. You heard a little bit from Nitiana earlier about some of the authorization issues. I think some of the most difficult issues may turn out to be around signaling and train protection, where, I mean, many of you again know the story of ERTMS, the fact we've been trying to get a single European technology deployed for the last 30 years now with limited success. But I mean, if they've got to interface with all of that, if they've got to interface with legacy signal systems, there are a lot of issues that they do have to deal with. And that won't be easy, however impressive the basic technology is. So I think a lot of scope, but I mean, we have to be honest that there are quite a lot of questions they have to answer as well.
Now, all of this is going to require financing, and that's part of the how. How do we get there in terms of investment? Now, Mikhail, the European Innovation Council has already financed Novomo with a top possible allocation of up to 17.5 million euros, I believe, both in grants and equity, and also in other UHS players as well, not just Novomo. Now, is the funding that EIC has awarded for the technology sufficient for UHC players to grow and to get to market readiness? And if not, what next instruments might be needed, might be helpful, so they can follow up with further developments and get this to market? And also, how could the EU, where we're sitting right now, how could they encourage, how can the EU institutions encourage more investment?
Well, the EIC provides blended funding. So they have already received a grant. Normally a grant of the EIC is 2.5 million. So that helps you basically deeper in the valley of death. And if you succeed, then you get, let's say, funding. So let's say equity or convertible loans, and that helps you through the valley of death. But then you have to grow. So yes, it helps you to survive longer and to test the technology, but the next challenge is to come with follow-up funding. And there are several options for that. One is to be very political. The Commission has made a proposal to the Member States to come up with a STEP plan, which is 2.8 billion euros. And the objective is to give follow-up funding for the current beneficiaries. So that's now a proposal that is with the Member States to decide on. And if that comes through, then basically it enables the EIC to offer follow-up investment, mainly in the most, let's say, strategic areas. So that's one option. The second option is that when Novomo goes in the hands of the fund part, it goes to the EIB, and the EIB is, in this technology, very well trained in providing further funding, so for funding for infrastructure. So the infrastructure side should come from the clients, and they can use funding that is available through the EIB. And the third one, I think that's an important message also for all my colleagues at the Commission, is that we have to look much better at synergies between instruments. And for example, I guess you use a lot of steel. The Just Transition Fund is a fund special for steel regions. Sometimes it can be with regional funding. So this is a topic where member states could look, or some regions could look at how can they mobilize their own fundings to have synergies with, let's say, the funding of what the ESC offers. What is very important is that we don't want to crowd out private money. So Ben will get, let's say, a fund from the EIC, but he will have to find as well a multiplier of private funding. And on average, EIC funds are multiplied by 3.2 in terms of attracting private funding. And these kind of events, of course, help, but also, let's say, the progress that Novomo has done.
So Ben, hearing that, we've got the European Commission headquarters right next to us outside the window, just next to you can wave to them. Yeah, and I mean, that's where the decisions are taken, right? So now that you've had this technological development, what would you expect, what would you hope for from the EU in terms of encouraging this technology?
Look, I think there are two main things that have just been mentioned to some extent and interconnected. The first one is the current work undergoing in a trilogue for 10T amendments. I think, for the current time frame, which will be 5-7 years, it will not change a lot in terms of implementation, but mentioning technologies like maglev, MagRail, Hyperloop will definitely send a very good signal. I don't think anyone should be afraid that these technologies will be able to, suck all the money from existing modes of transportation. It's simply impossible in this type of time frames, but sending such a signal that they are welcomed, that they are indicated for future funding, this will be very important for the private sector investment. What you have just said, this is something that's very important. And I think moving into some sort of transrapid situation that was there And as you said, it's sleeping at the moment. Maybe this is something that could be very interesting, because we really need a full-scale, full-fledged MagRail Hyperloop interoperability center, which I think could really position Europe very well. And what, Michel, you have just mentioned, a good, let's call it interoperability of funding, maybe let's call it this way. Because there are many instruments, but they should really work together, right? And I think this is what could be somehow navigated in these buildings here. Of course, we are more than happy with all the stakeholders to do as much heavy lifting as possible, but as you said, they have to sign, right? So I think if some coordination could be happening here, this would really accelerate the process, because in China, it's easier from many perspectives, right? Maybe not to live there, but to develop many things. Funding is unlimited, and the processes are fast if the decision is taken, right? So here I think we need to strike the proper balance between thinking it over, but also moving fast enough. And yeah, so 10T. And good funding for the next steps, because, you know, to commercialize booster, I think we have enough funding available. But for the full-fledged levitating MagRail, which will be done with industrial partners, being much more heavily involved than in booster, because we need to develop a new vehicle, signaling systems, compatibility, many topics that have to be assessed in a group of players. And getting, you know, maybe reactivation of Latin could be a very, very good idea for this type of projects, so that Europe can really lead the way with this technology.
Well, you mentioned the 10T regulation. So MEP Marinescu, the Transport Committee has adopted a compromise version of the new 10T regulation where Hyperloop and MagRail are included as next generation innovation, so they could be supported and promoted. What's your vision of the time frame and how they could be supported and promoted, and how they could play a significant role in the 10T network?
Yes, so I have a different opinion regarding TNT. It's okay that they are there, yeah, mentioned, but TNT is Transport European network, so corridors, maps, and so on. I think that in this moment, better is, and it will be, because I table already amendment, in STEP, in the platform for technologies that was proposed by the Commission before summer, because there is money. TNT doesn't have money. Yeah? TNT, it's providing some maps and the corridors. It's good that it's mentioned there. But STEP and ZIA also could be a solution, but only theoretically. So in NZIA, because NZIA doesn't have any money. There are mentioned some sources there that are always the same, but no money. But in STEP, there are not so much, but there are 15 billion. And there, it will be mentioned, I hope, because it's an amendment, let's see if it will be included, to mention the technology there, and then to have the financing. Now, STEP is coming also with in both, and ZIA could be there as MagRail technology could be there as a priority project, because you could consider that it's net zero technology. Yeah, so could be put it in the category of priority project, and STEP, the moment that will be there in NZIA, could take like Brussels, this building they have, I think, a special sector where they are inventing words. Now there is sovereignty seal. that's it. You know that in Horizon there is the seal of excellence. Now it's sovereignty seal. Why sovereignty seal? I don't know. But this sovereignty seal is for all projects that were evaluated and accepted in any other European fund, but without money. So it was under the line. So they are getting those projects, they are getting this sovereignty seal, so could be financing under STEP. So I think that the focus for money is now, in this moment, it's in STEP, because it's about digital technology, clean technology, yeah, and deep technology. So it's could be in any digital, maybe not, but in any category could be included.
So MEP Giesecke, do you share this idea that it's a nice to have, the mention in 10T, but that's not where the money is, it's not where the most need is? And also another question for you, I wanted to ask you about, the EU, this isn't the first experience with maglev in Europe. There have been experiences in the past that didn't work out, notably in Germany, your country. And we saw that actually that technology that was developed in Germany, the Transrapid technology, was eventually went over to China. It was instrumental in the development of next-gen maglevs in China. What was the lesson learned from that experience, from that German experience? And is there any possibility of that Transrapid technology or the lessons from that being used now to speed up development of UHS in Europe?
First of all, if it comes to the TNT, I think we had a good initiative report in the Parliament where first it was mentioned that we need this kind of innovative solutions like maglev, like Hyperloop. And in Parliament there was a broad majority from all political parties to have this in. And this is a big signal from the Parliament, which is important. And now we see, if it comes to negotiations with the Council, that there is much opposition to that. And the member states are not so enthusiastic about that. So there we have to work. Of course, Mr. Marinescu is right in saying there's no real money, but the political signal is very important. If it comes to the second question, lessons learned from Germany, of course, first of all, it was a tragic event and it has nothing to do with the feasibility. It was technically feasible and it worked, but it was an accident. So, and now we have in Shanghai the proof that this kind of innovation is running. One lesson which is definitely important is that within the sector from the rail, there was in Germany from Deutsche Bahn much opposition for new solutions. They wanted to run with the German high-speed train, the ICE, and they said, well, this kind of competition is not good because this kind of fast moving goods and passengers, it's just for our ordinary business, but not for new models. And we have to make clear that this is not, we have to go together to see that there is added value in new technologies. This is something we need to calm down the lobbyists from railways, poor railways. They have to see that there are other options. This is something which is really, really needed.
And the experience in Germany, do you think there's, I mean, in terms of the application, it's directly applicable? Or?
Well, you know, the Hyperloop and maglev is for long distances. And in Germany, of course, we have a federal system. And if we had the planning of having a train from Hamburg to Berlin, the people said, oh, I want to have one stop in Stralsund, one in Hiddensee. And so, you know, they did not see the potential is from Brussels to Warsaw, but not from Hamburg to Berlin with 10 stops. And so there we have to, there's a German federal system is not a model, so to say.
Well, actually, that dovetails very nicely into our first question from the audience, from Slido. Ben, it's a question for you. It's from Lara Tabe. Conscious that on a passenger service, the average speed is more impacted by line speed limits, comfort parameters like accelerating and braking, and the frequency of stops, what we were just talking about, rather than only on the technology adopted. So have you looked at what proportion of existing corridors would be suitable for these ultra-high speeds where you would want to be going a very long distance without stopping, for instance?
Absolutely. We've already started looking at it with our partners, with potential users. And from technical and operational perspective, there are solutions to this. For example, a study we did in Italy for one of the high-speed routes shows very clearly that once you can have 2 levels of service, right? Including, and you have it already there between Rome and Milan. Some trains stop on intermediary stations, some do not. And of course, we can do exactly the same here with MagRail. Even better because this system offers much more flexibility, shorter braking distances, and so on. So this is something we are looking at with users. And definitely coming back to the question whether this is a digital technology. It's absolutely fully digital technology, because for the first time ever we can control from the level of infrastructure real time the position of every train, of every wagon. And we can really manage it much more efficiently, and this will also help to get to higher average commercial speed.
So Kier, another question for you. So this summer, this first project, Made for Rail, was launched, which addresses maglev-derived systems. What are the JU's plans for the following years to support delivery of this type of technology through this Made for Rail project? Could you tell us a little bit about that?
Well, I mean, this first project is a relatively small project. It's only about 2.5 million total funding. I think 1.5 million coming from us and the other in match funding. And that's clearly about sort of going back to look at what was done in maglev to see what new things can be brought in, how that's now relevant to the transport mix of the future. So it's essentially trying to disinter it and see where we can pitch maglev alongside conventional rail, alongside Hyperloop, etc. I think where we go next, and I mean that's not just for maglev, but that's for Hyperloop as well, really depends on seeing where something is developing that actually from a European strategic perspective makes sense. I mean, if with maglev or Hyperloop, we really have the perspective to offer something which is going to help us with very high speed over long distances and thus with decarbonisation, I think then we would want to start focusing money on delivering that. I mean, clearly we're in the business of supporting all technologies and we're technology neutral at the moment. But if we see something really with the potential to make a difference, then that's something where we would want to focus. But at the moment, the JU's funds are pretty limited for the duration of the rest of this financing period. So, I mean, if we're to spend more on Hyperloop or on maglev, that would mean less has to be spent on other things. So that really means we have to have a pretty robust debate with the members or find more funding from elsewhere, but that's difficult. So show us the potential, and I think we will try and work on helping it go further is the basic message.
So Ben, I think this question would be for you, because I don't think anyone else on the panel could speak to it. This is from Robert Silk. I know this discussion is primarily EU focused, but we did talk about the US briefly before, I think, North America. Can you speak to the potential implications of MagRail technology in the United States? The United States does not have high-speed rail. There is really no realistic prospect of them having high-speed rail anytime soon, except for the Los Angeles to...
I don't want to sound like Europe-centric, but it's very difficult to find electrified lines in the US.
Is that so? So that would be an issue with UHT.
Concrete sleepers in the US.
Yeah.
Even though the share of freight trains in the overall mix is quite impressive, right? Because for heavy goods it's being used. Look, it creates, on one hand, some constraints. On the other, I think, a great opportunity, right? Because if the system is really well behind Europe and Asia, and there are significant efforts now and significant funding presented to change it, definitely this is something we are starting to look at after hitting the milestone announced today. In 2 weeks, we're going to present the first product, freight booster, which can move single wagons without or wagon groups without locomotive. This is a perfect solution for US markets. So definitely we are looking into it now. But of course, we need to grow a little bit more the company to be able to approach this market. which I think offers some sort of leapfrogging opportunity, which of course we would love to participate in.
Is the opportunity in a way then almost more tantalizing for the US because they're so far behind, that this offers an opportunity to skip high-speed rail entirely and go directly to ultra-high speed?
I think it's very difficult to answer this question very with a simple answer, because it's a complex network, a complex industry. On one hand, a bit easier because of the bound link, right? So the same companies run trains and own infrastructure. It offers some opportunities. Look, definitely we see US as a very good export destination for ourselves, but our roots are European, right? And we hope that this can become a European specialty, a specialization and an export hit.
And one last question. This is another question for you, Ben, from Lara Tabe. The opportunity is huge. Will you be able to share numbers supporting the claim double the capacity, half the travel time, and associated costs?
Stefan, do you want to take this? Okay. Sorry, so once again, the question?
So we may have Casper still on the line. I'm not sure. So the question is, can you share the numbers supporting double the capacity, half the travel time, and associated costs?
Okay. So double the capacity, we've run already several feasibility studies with major European infra managers and operators, and these are actual numbers that we are getting. Of course, this is up to double capacity, and it depends on a specific line or port or terminal. Then half the travel time. We've shown the example of routes from Brussels to Paris or Brussels to Berlin, and it's quite obvious that comparing to other alternatives, we can get there. And on the cost perspective, we're talking about 1/5 of the cost of building a new maglev line. So we say that it's up to half of the cost of alternatives. Because 10 million per kilometer for the levitating version is 1/5 of at least 50 million that we have to spend on a maglev line.
Well, we'll wrap up the second panel there. How about a round of applause for all of our panelists? And we're going to close out the evening with our final keynote address from MEP Marinescu. If you could take the podium now.
Yes, thank you again for the invitation. So I think that this is a very interesting discussion. Since we met first time, I understood that this is a very good opportunity to try to solve the slogan "Shift to Rail," because for the moment this is a slogan only, yeah, because there is no rail. Yes, there is no capacity and so on, but this, because they can use the actual rolling stock, it's a very good opportunity. But I hope that it will be managed by the, let's say, Commission, by everything that it's, we are saying that it's EU, not in the same way as ERTMS. That it's not a success, it's not a failure, but it's somewhere in the middle. It's not interoperable, it's not deployed where is necessary, it's very expensive, it's not using satellite technology and so on. So it's in the hands of the companies that they want to sell their products, and that's it. They don't think about railway. I heard here something from Jens also regarding the operators, Deutsche Bahn, SNCF, and the others, that they are not so happy to go on the new technologies. That's very clear. They are not happy to introduce interoperability, to harmonize the regulations and the signaling systems and so on. So they want to keep the status quo because it's profitable for them. And this, you have to take in account this, because this will be a problem. Now, about implementation, will not be easy to implement. That's very clear. Yes, because it's necessary money. And people to want to implement this. So your chance is to find operators that they want to use this technology and to be partner with you for a small project and then to enlarge the project. So FC is one of the possibilities for financing, and now STEP, because again, TNT, it's okay, it's good that we mentioned the technology, but the money is in CEF, and connecting Europe facilities is already crowded with projects. So it will be difficult to enter in this. To build, as you said, new lines for this technology will be very expensive, but you have to base your approach on the map, which is in TNT for high-speed train. There is a map with such a line. So the last thing is that you discuss about replacing short flights. Yeah, you know that I am dealing also with aviation. This is also a dream. Maybe you can do it, but till you will do it for flights of 400 kilometers or 500 kilometers, it will come the electric plane. I hope that it will come for a small number of seats. Yes, and this will be very good. But this is again a slogan. You know, they are saying that to replace the short flights because of emissions. 5% of the aviation emissions are in short flights. The other 95% are in long haul. So it's not even a big reason, but it will damage a lot. It will impact a lot the life of people and the economy, because short flights means connection between regions and between people. So this will not be a good effect. So I wish you all the best. I believe in this technology. As an engineer, it's fantastic. I hope that you will find, you have next to you a person that is sitting on a lot of money. Yeah? Yes, Horizon has a lot of money, and I hope that they will invest it in real things like this one. Because Innovation Council also, but all the other things from lines from Horizon, because now they are investing a lot in universities. It's good to have fundamental research. Now it's collaborative research. It's another word from this building. Yeah, but we need to invest in innovation with a market value. Innovations that are solving our problems right now, today. Not in other things. Could be, yeah, part, but not so much as now. So that's the way, and I wish you all the best and good luck, and I hope that you will succeed, because it's for our benefit. Thank you.
Thank you very much, MEP Marinescu, and thank you to all the speakers we've heard from tonight. I think they've given us a lot to think about and a lot to be excited about, really, when we're thinking about the future of transport and the different options and technologies that are becoming available. So thank you to all of you for spending your evening with us. The temperature in here was pretty high, but I have great news, which is now you can have a drink outside, just outside these doors. So I encourage you to do some networking, talk more about the future of rail, and pass it off to some final words from Ben.
So thank you so much to everyone for being with us online and physically here. Thank you again. Great to be with so many friends in one room. It wasn't easy to get us until today, because when we were starting 6 years ago, we didn't have so many friends. everybody was looking at us like, what are you talking about? So I think the road until now has been bumpy and long, and I hope this meeting will help us to accelerate it and make it one without turbulences. Again, special thanks to the team, without which we would have never got here. One more special thanks among team members, because I'm not going to mention everyone once again, to Jacques Berebi, who is a Brussels citizen, but unfortunately he wasn't able to join us because he had to go to Florida, but I think we have Florida outside the window today. Jacques is our investor, co-founder. Many thanks for all your support, Jacques, and for being with us online. We're heading towards the destination networking, as Dave said, so enjoy the drinks. Thank you so much. Just one final comment, trying to embrace what has been said so far. I believe strongly that ultra-high-speed transportation can become a European specialization, but it requires a strategy and execution. And as one of our potential investors claims, hope is not a strategy. We should really start working on this and put it on paper and then execute it. And I hope we can count on all of you being here. And coming back to the discussion we had in Warsaw a couple of weeks ago about European specialities and how many really, great digital companies, technological innovations have been created here over the last 2-3 decades. I think we have a lot to catch up and really don't want to end up as a greatest tourist and luxury goods continent, because this is for the moment the speciality. And I think we have a lot to catch up, and let's hope this revealing of the critical milestone done today and this energy filling this room can bring us there. Thank you.
Thanks, everybody.